Okay, so binomial distribution, here's some formulas. So this one is called the mean. And this one is the standard deviation, the bottom one. This one is variance, which I will not use at all. Okay, if you don't know, they're on here. So on that formula sheet I gave you, those little symbols are up here. So there you can see standard deviation, and then there you can see the mean. No. Okay, a flight holds 220 passengers. The probability that a passenger does not show up is 5%. Flights always overbook, and they decide to sell 225 tickets instead. So is this going to be a good decision or not? Okay, so here we go. Mean equals the number of tickets, the n is the number of tickets, so 225 times the probability. So the probability of people coming is, this is not coming. So the probability that they're going to come to the flight is 95%. So this is just like, how many people are you going to expect to come? Because if you sell 225 and 95% of those people come, okay, so you're going to expect almost 214 people to come to the flight, which would be good, right? Because you have 220. Okay, standard deviation equals the square root of n, so that was the 225 tickets, times the probability of showing up, 95, times q, so q is the not. So P is the show, Q is the not show. So then that would be 0.05. So P and Q are always the opposites, or like to add up to 100%, right? Okay, so here we go. We're gonna go Z scores. Okay, so here's what we are thinking about. If we hold 220 passengers, it would be bad if we were more than that, right? That's the problem. So we're gonna go, what's the probability of being above 220? Okay, so I'm actually going to just use a 220.5. So that's what I'm worried about. Do you remember the z-score formula? Minus the mean over the standard. So that's that z-score formula on your sheet, minus the mean over the standard. Okay, so getting a z-score, okay, so this is me trying to figure out, I'm trying to figure out what's this likelihood that I'm going to oversell this plane. Okay, so I have a Z-score now. So what am I going to do?
Look at your chart.
Look at my chart. 2.06. Gotta have my ruler. My eyes don't work as good as they used to.
2.06.
Getting 48.03, that one. So that's the percent between where I am in the middle, right? But I want to know the over percent, so what should I do to get that side of it? 50 minus. Okay, so there is a 1.97% chance that your flight gets overbooked. Would you do it? Would you sell that many tickets, risking it?
Risk.
Think about how much extra money you can
Yeah. Thank you, Piper.
I would say that's a good decision, business decision, to sell those 5 extra seat tickets, banking on those people not coming, because there's only a 1.97 chance that you would end up overbooked.
I'm not risking anything.
That happened to me when I was 7 years old. We went to Disneyland, and I remembered coming home, and then they were like, "This flight is overbooked. We're offering, like, whatever, $1,000 credit to, or like whatever, or a free extra flight somewhere." Yeah, I was 7. Don't remember much.
Summer?
When I was 7. So not this summer. It was more like 1992.
More like 30.
Okay, this time we got 211 seats on this plane, and we decide to sell 234 tickets. Okay, you ready? So the mean, if we sell 234 tickets times what probability that people are coming. So I need you to do the 1 minus this, because this is the not showing. So can you give me a 1 minus that probability? So this is the likelihood that they're coming. So how many people should we expect? 218. Ooh, that's not good. If we're already expecting that many, and there's only 211 seats, this probably isn't going to be good. Okay, standard deviation is the square root of that n number times the p probability times the opposite probability. Okay, so I can already kind of tell you something. If my mean is at 218, and I'm worried about selling 211 or more, or I'm worried about being over 211, yikes, this isn't going to be good, right? Because look at how much chance you have. Okay, so let's get the exact probability that would happen. So I'm worried about being above 211. I'm worried about that. So I'm just going to use a 211.5 as my number, minus the mean over the standard. Okay, that's that formula. It's on your sheet again. Okay, so what did you get there? Negative 1.77?
-2.
No, negative
Maybe I typed it wrong.
176.
Oh, I typed it wrong.
And you got something different than that too?
That's what I got too.
This is what you got? Okay, so I'm gonna go 1.77. Chart time. 4616 on the chart. So that's your location to the middle. But now I'm going to actually have to add that on. So what can you conclude about this situation? There's a 96% chance that the plane gets double booked or overbooked. Not good.
Wait, where'd you get the 4.246?
The 4616
Yeah.
chart,
Oh, chart.
1.77 chart number. Okay, last question today. A hotel has 300 rooms. Probability of somebody not showing up is 15%. So I'm going to quickly write here that their showing up is 85%. Okay, so the mean is that we have these 300 rooms. And there's an 85% chance that they're coming. People are coming for the room. Which means you're going to expect 255 guests. Standard deviation, square root of that. The p probability, the opposite probability. So then the question says the probability that more than 275. So I'm looking for being above 275. That's my situation. So I'm going to go Z equals 275.5, just so I'm kind of being above it. And then minus the mean over the standard deviation. Okay, so I'm going to figure out this being above it. What's the chances that... Okay, so I need you to look up 3.32. Ooh, our chart just barely has that one. 3.32. And you get a 0.4995. Mental math without your calculator. What's the left over here?
0.05.
0.0005. So 0.05%.
I use the calculator, so.
Okay. So not very likely.